Today we're going to do a review of what molecular compounds are in covalent bonds, and then we're going to go over how you name molecular compounds and how you name very basic organic compounds. Just a review from the video you watched the other day, a covalent bond is when we have two atoms, two nonmetals that come together and share electrons. And the formation of that bond creates a molecular compound or a molecule. And so just as an example, we can look at hydrogen. So hydrogen has one valence electron, and when two hydrogens get close together, there's an attraction between that electron and the nucleus of the other hydrogen atom, and so they come together and share those two electrons. And if you remember, hydrogen only has one orbital, it just has a 1s, and so that leaves that orbital completely full with two electrons, and both hydrogens are very happy and share those two electrons, and that is our covalent bond. And what we have here is H2, which is a molecule. Now the way we name molecular compounds is using prefixes, okay? So these are the prefixes, which should be somewhat familiar to you. So mono, I think a lot of you would know, means one. Di is two. Tri, like a tricycle with three wheels, is three. Tetra is four. Penta, like a pentagon, is five. Hexa, 6. Hepta is 7. Octa is 8. Nona is 9. And deca is 10. And they go up further than that, but that's as far as we're going to learn for this class. And they're the ones that we would encounter most commonly. Okay, so when we name these, we always change the name of the second nonmetal to "ide," the ending, just like we did with ionic compounds. And then we use the prefixes to tell how many of each nonmetal are present. So with molecular compounds, we don't have charges like we do with ionic ones, so there's nothing about the name that would imply how many there are. So we use a prefix to help us figure that out. And also, if you have a situation where you have two A or O vowels that would appear together because they're both in the prefix and in the first letter of the nonmetal, this is most commonly seen with oxygen, then you omit the vowel from the prefix. So if it was mono and oxide, you would take the O off the mono and it would be monoxide. Or, for example, tetra and oxide, you would get tetroxide. All right, so let's do a couple of examples of these. Okay, so for this first one, we have silicon, and then the second nonmetal is bromine, but we're going to change the ending to "ide, and there are 4 of them. So it's going to be silicon tetrabromide. All right, the next one is hydrogen, that name just stays the same, and then the second nonmetal is fluorine, so we're going to change the ending to "ide. Now, this is a case where we could do hydrogen monofluoride, but that doesn't happen very often. Usually, really the only common example of that is carbon monoxide, and that's just because that's the common name of that one. I, on a test, would accept either, but you never put mono before the first nonmetal, only occasionally after the second one. All right, so this would be hydrogen fluoride. All right, dinitrogen oxide tells us that we have nitrogen and oxygen in a compound together. The dinitrogen means that there are 2 nitrogens, and there's nothing in front of the oxide, so we would assume that there's just one. So it's going to be N2O. Okay, and then the last one is carbon tetrachloride. There's no prefix before the carbon, so we would assume just one carbon. Tetra is the prefix for fluor, 4, and chloride means that we have chlorines in there. So it's going to be C for carbon, Cl for chloride, and 4 of them. So carbon tetrachloride is CCl4. So now we're going to talk very briefly about the simplest of organic compounds. So organic compounds are ones that are made up primarily of carbon. That's what an organic compound is. And hydrocarbons, as their name might suggest to you, are ones that are primarily hydrogen and carbon. Okay, and they're a type of organic compound. So the ones that I've shown here have all single bonds. I know we haven't talked about double bonds or triple bonds yet, but these have all single bonds, and they're called alkanes. So alkanes are hydrocarbons that have all single bonds, okay? And they have a naming system for each of those depending on how many carbons are in the structure. So methane is just one, and that starts with an M, like mono, so maybe that will help you remember it. Ethane, I don't really have a good way to help you remember that that's 2. You just have to remember it. Propane is 3. Butane is 4 carbons. Pentane is 5, and so now we get into the prefixes that sound like the other ones. Hexane 6, heptane 7, octane 8, nonane 9, and decane is 10. Now the formula for the hydrocarbons that's shown over here tells you how many carbons and how many hydrogens, but it doesn't give you very much information about the structure. So sometimes we show the condensed structure, which is over here, and that tells you the number of hydrogens after each carbon tells you how many is bonded to that particular carbon. And you should be able, or you can figure that out, because carbons always make 4 bonds. And so the first one is only making bonds to hydrogen because there's only 1 carbon there. So it's CH4. And then as you add carbons, now the carbons are going to make bonds with each other, and so there will be fewer hydrogens bound to each one. And you can see that all of the carbons on the end have 3 hydrogens on the front and the back end, and all of the ones in the middle have 2 hydrogens. So you can figure out how many hydrogens are in a given hydrocarbon by doing the number of carbons times 2 plus 2 more for 1 on each end. So now we've gone over all the different kinds of namings that we're going to learn for this class, and I've made you this nice flow chart to help you figure out which naming system you need to use. So far I've only given you a specific type of compound, and you've known which kind it is and then have to figure out how to name it, but in reality you're going to get a compound and you have to figure out which kind it is and therefore which kind of naming system you're going to need to use. And so I provided this flowchart for you. You don't have to use it if you don't find it helpful, but a lot of students find it to be a good way to determine or help narrow down which type of naming system they're going to use. So it basically comes down to first determining whether or not it has a polyatomic ion. If it has a polyatomic ion, then you know that it's ionic, and if it doesn't contain any metals, then you know that it must be covalent, and so then you can figure out whether you need to use molecular naming or the organic naming we just did for alkanes. Right, so we're going to do lots of practice with this in class, but maybe bookmark this in your notes so that you can find it easily to help you when you're doing practice problems.